dojo? Bow to your sensei. Bow to your sensei. We're on to our next challenge, Playing with Cubes 1. You are to create a public class called Cube without a constructor, which gets one single private integer variable side, a getter get side, and a setter set side. That takes an integer parameter. Method for this property. Actually, getter and setter methods are not the common way to write this code in C#. In the next kata of this series, we are going to refactor the code and make it a bit more professional. So that's all true. This isn't the way we'd actually do it, but it's good to know what properties are doing on our behalf. You should understand getters and setters. You'll use them, if not in C#, then in other languages. A couple of notes: there's no need to check for negative values, and it says to initialize the side to 0. Okay, so this is kind of a good first introduction to classes and object-oriented programming. We're going to create basically about as simple of a class as you can get. We're not even doing the constructor, so we'll get rid of this. Classes you define this way. You have the access modifier, which is going to be public, so it's accessible, and they provided us with the name of the class, but whatever name you would have for your class you could enter here if you're working on something else. And then you have a scope, like with a method. These curly braces will define your scope. Everything within these curly braces is part of your class. So the first thing they mentioned to make was a private integer variable called side. We're going to make that private like they told us to. Private int for integers and side. I don't name my private variables with capital letters, but I'm just copying what they're doing here. You can look into common formatting methodologies for teams if you want to see best practices on that. But typically capital letter stuff is reserved for publicly accessible things. But we'll turn that off for now. We'll just do what they're saying. Private int side. So there's our integer variable. If you remember in the notes, they told us to initialize it to zero. So I'll do that. And then next we'll move on to these getters and setters. If you haven't heard that term before, getters and setters are methods that set and provide the value. So if you notice, we were told to make side private, which means if someone makes a cube object, they can't just say cube.side because this is private. They don't have access rights to it. So what the getter and setter do is allow you to access that value and modify it publicly. They give a public interface for doing that. And my own personal preference is to put public stuff before private stuff. I like when people look at my classes where they can just see everything public at the top, because the public portion describes the interface of the class, how users interact with it. They don't need to know all the private dealings of how the class works and produces the right output. They just need to know what methods they're supposed to call and be able to understand when to use those. So I just keep it all right at the top so someone doesn't have to go scrolling around, hopping around in my class to try and figure that out. But feel free to order things how you like. So getters and setters, like I said, are methods. So we know that after the access modifier, we have to specify a return type. In the case of the getter, the side variable is an integer, so we are going to return int. They gave us the name, getSide, and again we have curly braces that define the scope of the method. Everything within is part of the method. In this case, all we have to do is simply return the value. Return side. And we are going to do something similar for a setter method. Public. In this case, think about what set does. It's going to modify the value of side. It allows users of our class to change the side value. So we don't need to return anything, right? Sometimes with methods that modify, you'll see they return a Boolean that might denote if the operation was successful or not. I'm not going to worry about that here. We'll just say void set side, and it takes an integer as a parameter. And this will simply, we'll say side, equals whatever new value that the user passed in, right? They changed the value, side equals num. And so you've updated side. And to get it again, you would just call cube.getSide to access that. So really, I think we've complied with everything they've asked for at this point. And we should mention, why would you go to the trouble of doing this, right? You may have thought, hey, what if I just went like this? Why can't I just say public side like this? And now everyone who is with the cube class can just say cube.side and knock themselves out and do whatever they want with it. The problem with this is that it breaks an idea of object-oriented programming called encapsulation. So we typically want to we want to control our own data. We don't want it exposed to the public where they could do something bad, they could corrupt the data. In this case, with how simple this is, notice that we're not doing any kind of checking on the input. This is effectively the same thing, but you can imagine that they even gave this idea here, there's no need to check for negative values. Well, says who? You could easily modify this to say if num is less than 0, i.e. negative, set side to 0, or something that prevents it, or throw an error, or throw an exception, something like that. So that's why you don't see people doing this. It's a good common practice that all of your data should be private, and you provide data on a limited need-to-know basis where it makes sense, and no more. By setting up this infrastructure here, where we've got methods that handle it, we have control. We can come in here and say if num is something that we don't like, or do whatever we want, any kind of checking, validating of input. It gives you that layer of control that you wouldn't have if you just made side a public variable. So that's why we do things like this. So yeah, encapsulation, feel free to read more about that concept if that's not clear. But you could also make an analogy of, like, if you ran a business, right? You wouldn't leave your your private records accessible to the public, right? If you provided some kind of service, maybe you do taxes or something, right? And you wouldn't just provide people's tax information or private data. Maybe you run a clinic and you're not just going to give out people's private information that others could abuse their social security numbers or anything like that. That analogy may be too harsh because typically the people that you program with, they're not malicious, but you still get bad input from blown calculations or whatnot. So, and you're responsible, ultimately for your class. If it doesn't handle edge cases well, if it doesn't respond appropriately, if it doesn't halt the program when it should, you're responsible for that. You got to make sure input's formatted in a way that's right. You don't get to go blame other people for doing that. So take ownership of your classes. Yeah, that's what I have to say about that. So we'll run the test on this. Hopefully this covers it. No typer namespace and definition end of file expected. CS21 public. Oh, sure. Sorry, I blew that at the very beginning. Feel free to take a comment. You're probably screaming at me throughout this whole video about the keyword that I missed. But at the beginning, it should have been public class. I gotta say this is a class. So, yeah, you can tell I work in Visual Studio a lot. Normally when I create a class, that kind of stub, that boilerplate is just already dropped in place for me. So I apologize for that. Missed the class keyword, but yeah. Good. Tests look good. It's really not much going on here, but it's just meant to be an introduction to object-oriented programming. So we'll run the larger test. Good. Looks good. I'll submit this. But again, get into this habit. I know it seems a lot less typing to just say public inside and go about your business, but you're going to have a mess on your hands if you leave all of your data just flapping out there in the breeze, and anyone anywhere can manipulate it. It's a nightmare once you start scaling up the size of your programs. When they're small like this, it doesn't seem like a big deal. It probably sounds paranoid, but when you get at scale, hundreds of classes, thousands of lines of code, you're going to be very thankful that you put precautions in place that allow you to control things. So that's about it. Hit me up with those questions. Otherwise, we'll move on. Thanks. I suppose we'll do the submit. See if there's anything going on there. Yeah, what you would expect. So, again, thanks for watching. See you in the next one.